Okay, welcome to your final exam review, page 6. Number 35. Okay, here we go. The rule with these things is if you don't know what to do, change everything into cosines and sines. So cotangent can be written as cosine over sine. Secant can be written as 1 over cosine squared of x plus, let's see, cosine of x over sine of x. Big old division bar, 1 over sine squared of x. Now, some people may have combined denominators. There are several ways to do this problem. This one seems to be the smoothest. So if you do it a different way, that's fine. Times the reciprocal, cosine squared over 1. So that looks like a little bit of trouble there, but we'll solve that in a second because of the cosine cubed coming up. Cosine x sine x times the reciprocal sine squared x over 1. Now you may think about canceling here, but if you notice, you already have a common denominator. And if you see it up top, you might want to factor out that cosine right away. But let's just say you followed your nose and you wrote cosine cubed. Then over here you wrote cosine of x times sine squared of x. Okay, so just take a moment and look, what would you do next? Like the only thing that's left to do is to factor out that cosine of x. And if you see a little gem in the inside, you get cosine squared x, sine squared x, our good buddy, who's equal to 1, all over sine of x. And what you're left over with is cosine of x over sine of x, which is equal to cotangent x. Okay, that was a pretty good one. I like that one a lot. Number 36 is about sketching. I think there's a typo in that problem, so we crossed it off. But you are responsible for sketching. And just a heads up, while you're going through your notes, think of x and intercepts. Think of y-intercepts. Think of vertical asymptotes. Think of horizontal asymptotes, how you find those. And if all else fails, just start graphing some points, plot in some points and see what comes out. Also watch out for, those horizontal, those oblique asymptotes too, okay, with some long division. I don't know if that's for at least synthetic division maybe. Something to think about anyway. Anyway, here's number 37. Let's talk about solving this triangle. So they gave you two angles and a side. That's screaming what? Law of sine. So sine of big A over little a is equal to sine of big B over little b is equal to sine of big C over little c. So they gave me A and C, so let's go ahead and use those. So that would be sine of 95 degrees, okay, be careful with that, over 12 is equal to sine of 40 degrees over C. Cross products, here we go. So C is equal to 12 times sine of 40 degrees divided by sine of 95 degrees. And if we plug that into our calculator, let's see, so 12 times sine of 40 degrees, okay, divided by sine of 95 gives us, we'll write 7.743. Okay, so what do we have? We have C. We have to go get B, so we can get that angle B pretty easy. Let's see, that's just 180 minus 95 minus 40. Okay, and if you do the math there, 180 minus 95 minus 40 is 45. Okay, so now you have this guy done. Degrees. And finally, we can do sine of 45 over little b, because that's the guy we're missing down here. I'll just continue using a. It doesn't matter which one you use. All over 12. So b is equal to, be careful here, 12 sine of 45 degrees over sine of 95. Take it slow if that was too fast. I kind of flipped and did everything at the same time. And 12 times, let's see, 12 times sine of 45 divided by sine of 95 gives us 8.518. Okay, so it looks like we got everything we need. We got all angles and all sides. Okay, here we go. Oh, that's a nice hint. They're telling us there's two triangles out there. So there's a nice diagram you can draw to see this stuff. And anytime you want to solve two triangles, this is the diagram I want you to draw. So all you have to do is draw a triangle up like that, down there, and I call it the pyramid. So you can kind of see a pyramid in there. It looks kind of nice, and it'll help us out with this problem. So the only thing you have to be careful with is that this is kind of written backwards. So we know the rule says for this one we could change it, but realize that they give you the angle C, and C is less than A. So that's the same thing as saying given A and A is less than B, there can be two triangles. That's the rule we know. So we just have to label it a little bit differently. It still works out the exact same way as I taught in class. So let's start out here with C, and we'll call that 72 degrees. And then I'll call this guy B, and I'm sorry, no, A, because that's the guy that I'm after. And we'll call this guy B. Okay, so what do we know? We know little a is 27, and we know little c is 26. So with this diagram here, you can see that I can change, this angle and this angle. I can just, in other words, I can just slide that same length over there, and you can see that that I can get two triangles out of this one. So with this side and this side given, I don't know why I wrote degrees on there. I'm sorry, C is over here, so I apologize for that. So 26 is over here, and you can see that I can change this angle here and swing the door that way without messing with 27, 26, or 72. So once I find A over here, I can go find this, we'll call him A prime over here in my second triangle. Okay, so then maybe I'll take these two triangles apart. So here's the first one, it looks like. All right, let's go look at him. So that's C, that's A, and that's B, and I know that's 27. And I know that's 26, and yeah, with the same length, you know that this guy is 26 as well, and you know that this is 72 degrees, and off to the races. So here I could just say, okay, sine of 72 over 26 is equal to what? Sine of A over 27. So this is where we have to use the inverse function on our calculator. So sine of big A is equal to 20 times sine of 72 divided by 26. So sine of big A is equal to 27 times sine of 72 divided by 26, and we get 0.988. And if you sine inverse that guy, let's see, second sine inverse, second answer, we get 80.981. All right, that's nice. Okay, so did I solve that triangle? Let's see. I have big A now as 80.981 degrees. And what can I get next from that? Okay, so then I can do 180 minus 80.981 minus 72, and that gives me, let's see, 180, long problem, minus 80.981 minus 72, almost there, keep going. And that's 27.019. So that would be right here. So that would be 27.019. And finally, we got to go find little b. So that would be sine of 27.019 divided by, that's degrees, divided by little b, which we're looking for. And let's see, that would be sine of, let's just use C, 72 over 26. And, okay, so B gets up there. That's a 26 cross products again. Sine of 27.019 degrees, all divided by sine of 27 degrees. Okay, excuse me, one more time. 26 times sine of second answer, still in my calculator, divided by sine of 27. Looks like I got 26.017. Okay, let's see. What would that be? So that'd be a 26.017. That kind of makes sense in terms of relative to the other side. So it looks like we're pretty good here. Except for now we got to figure out this second triangle. So let's go ahead and see if we can construct them. So he would be what? This part of it, okay? And we know that C was given to be 72 degrees. And now this new one we got, did we do the math somewhere? No, not yet. So how do I find this guy's counterpart? Well, he's just the supplement of him. So then I'm just going to take 180 and subtract this number, okay, the very first angle we had, okay, and this is not drawn to scale by any means, but that's how you find it. So 180 minus 80.981 gives us 180 minus 80.981, 99.019, 99.019, okay, 99.019, okay. Notice one's less than 90 degrees, one's more than 90 degrees, so that's a nice fact. Okay, so now I have this angle here, and I was given in the beginning that across from C is 26, so we know that's 26, and we were told that A was 27, so that was the A prime. So this guy is still 27. He hasn't changed. The only thing that has changed is this little b and this big B. That's the only thing other than the A prime. Okay, so let's get angle B first. So that's 180 minus 72 minus 99.019. Okay, calculator. One more time. 180 minus 72 minus second answer, because he's still there. Did I do that right? Yeah, I did. That's 8.981. I feel like I did too much here. Nope, it's a really small angle. What can I say? And okay, and so now we have to get little b. So sine of big B is 8.981 all over little b. I'll stick with C, sine of 72 degrees over 26. And let's see, so I do it kind of quick. So that's 26 times sine of 8.981 divided by sine of 72, and B is equal to 26 times sine of second answer, he's right there, divided by sine of 72, and our answer is 4.268. Okay, so that's great, and under 15 minutes, so that was kind of long, but yeah, that's a good one, huh? That's a nice long problem there. Remember, the trick is as soon as you find the first angle, because that's the only one you can get, just subtract it from 180, and that'll be the start of your next triangle. But this period diagram really came in helpful. I'm going to use it next year. Okay.